sure it's recording?
All right, there's no school today on Tuesday, so here's the video we promised you. We are going to start by asking you to do this beautiful warm-up. Okay, I'm going to let you try.
And you said this was going to be a fun one.
It's always fun. All right, if you use long division, you're probably somewhere stuck in the middle. It's taking you too long, especially you, Riley. But if you use remainder theorem, you're probably already done. Just to refresh everybody's memory, using the remainder theorem says we're going to take this value in x minus c, which in this case is 2. If we substitute it into the polynomial, whatever remainder we get is going to be the same remainder that we would have gotten had we done long division. So let's just test it out. Throwing in a 2, we get 2 to the third power plus 4 times 2 squared minus 5 times 2 minus 14. Continuing on with this order of operations, we get 8 plus 16 minus 10 and then minus 14. 24 minus 10 is 14. 14 minus 14 is 0. It's beautiful. We love it. What does that mean? When I use the remainder theorem and I get the value of 0, it means that this piece, x minus 2, is a factor. It's a factor of the polynomial, so I could write it as x minus 2 times something will get me this crazy polynomial up here. We'll talk about what that something is going to be in a minute. But what it also means is that this part, x minus 2, is going to give us a 0 for our polynomial. So in this case, our 0 is 2. So if I think about the graph of this, if I try to graph this polynomial, it's going to cross that x-axis at the number 2. So, you want to jump in on this or no? Okay, so now, if those of you that were doing long division are still doing long division, I'm sorry, we're going to move on to teach you a second method for dividing called synthetic division. Synthetic division!
A super lit method.
Okay, through this video we're going to show you 4 different examples. Starting now, and we strongly suggest that you pause them, or the examples along the way, pause the video, so that way you can try it for yourself, but we're definitely going to continue through all of the problems for you. Okay, so instead of taking a long time setting up this long division problem and going through and then multiplying everything out and then adding and subtracting and trying to figure out what the remainder is, we have this other option called synthetic division. So we put the steps right here for you. Step 1 is going to be to set up synthetic division by writing your coefficients and your C values. So the way that we set up synthetic division is with this crazy looking L. Okay? And then we want to make sure that we have enough space over here because we're actually going to end up having 2 lines. But on the top line, we're going to write all of our coefficients from our polynomial. So n to the third power has a coefficient of 1. N squared has a coefficient of 7. N, the linear term, has a coefficient of 14. Thank you, switching the markers for you. And finally, our constant term is just 3, so we write that right there. This C value is, when I look at this binomial, what value is going to make that 0? If I think about n plus 2, a negative 2 will obviously make it 0, so that's the number that goes outside. Okay, so that's how we would set up synthetic division. Step 2 says bring down the first coefficient. So literally whatever number is here, draw an arrow, write it all the way down at the bottom underneath that line. Now we're going to multiply it by our C value. Negative 2 times 1 is negative 2. So now we start that second line. Step 3 was multiply, we just did that. Step 4 says add the columns. So 7 plus negative 2 gives me a positive 5. And now we repeat. 5 times negative 2 gets me negative 10. Add these two numbers. 14 plus negative 10 gives me a positive 4. One more step, or one more time. Negative 2 times 4 gets me negative 8. Write that number right here, and add my columns down. And I end up with negative 5. This number that's left over after you're finished all the way through, there's no more other numbers to bring down or to multiply by. This number is your remainder. So negative 5 is going to be our remainder for the division of those two polynomials. And I actually know what that polynomial is. If I follow it, this would be x to the 0, x to the first power, and x to the second power. And those numbers, again, are my coefficients for my new polynomial. So I can write this entire answer as x squared plus 5x plus 4. And then I would have my remainder minus 5 over n plus 2. And so this right down here is my final answer. If you use long division, you would have gotten the same thing. Maybe you have some questions. Feel free to send us messages on Remind, but stay tuned for example 2.
At this point, I suggest you pause and try it on your own. So for following our steps, we're going to first write that weird L looking thing, and I'm going to get a marker that works. Weird L looking thing. Apparently doing this really large. So I'm going to write our coefficients. So my first coefficient is going to be my p to the third coefficient. My next one is going to be my p squared coefficient. Then my p to the first power coefficient, and my constant term, which is p to the 0. And then, like Ms. Neubauer said before, I'm looking at when this thing is 0. So if we, whoops, nice p. If we look at this, when is this going to be 0? Well, I can add 5. So I get p equals 5. This is my c term that I'm going to write outside here. Okay? I'm going to start by bringing down my first coefficient. And then I'm going to be multiplying 1 times 5, which gets me 5. And then I'm going to add down, which is going to be negative 5, and then repeat that process. So 5 times negative 5 is negative 25. If I add those guys together, I get negative 5. And finally, multiply one more time, and I get negative 25 again. And this, add them down, and I get positive 1. So I'm left with this, as Ms. Neubauer said, is my remainder. This is going to be my constant term, my p to the 0 term, p to the first, and p squared. So as you can see, this is not a factor. That also means that 5 is not a 0 of the given polynomial. So now let's write our answer. Great job! Next.
Example 3. I don't know where the cap is. Oh, perfect. Okay. Suggesting right now that you take a minute and pause and see what you can do to set up this synthetic division to start. Okay, hopefully that was enough time. If not, we'll do it all together right now. Or actually, if not, pause it. Use markers. All right, we have our L. We are going to, just give me all of them. We are going to write my coefficients up at the top. My x to the third term, my x squared term, my x term, and my constant term. Again, thinking about what that c value is, we need to take a look at when this piece, 5 plus 2x, will equal 0. So if we're thinking about that, we're going to subtract 5 and divide by 2. I get 2x equals negative 5 or x equals negative 5 over 2. Oh no, a fraction! I can't do this problem. Wrong. Negative 5 over 2 is your C value, so deal with it. Yes, you need to multiply by fractions. Bring down your 2. But we made them nice for you, okay? Negative 5 over 2 times 2, the 2's cancel. I'm just left with negative 5. Again, now I'm going to add these two numbers and get a positive 12. So nice that it's an even number again. Negative 5 divided by 2 times 12. The 2 and the 12 will create a 6. 6 times negative 5, negative 30. If you don't know how to do that, just a little sidebar over here. Negative 5 over 2 times 12 over 1. Make that a 1, make that a 6, negative 30. If you don't know how to do that, please come and see us after school. Add them down. Positive 8. Again, even number, beautiful. Negative 5 over 2 times 8 is going to get me a negative 20. Final step, add them down and end up with negative 5. This right here, that's my remainder because I have nothing left over here. My synthetic division has stopped. So again, this means that this 5 plus 2x, not a factor of the polynomial, and negative 5 over 2, not a 0. Writing our final answer, this is my x to the 0, x to the first power, and x squared term. And my coefficients are my beautiful numbers that I created using synthetic division. Writing my remainder as so. Ta-da!
All right, example 4. I think I'm gonna go all out with this one, Miss Neubauer.
Go for it.
All out.
Love it.
Take a second, try this on your own. All right, let's see how you did. All right, if I'm looking at this, I see x to the third, x squared, and then the constant term. So what are we missing? The linear term. So we have a plus 0x happening in here. So we need to remember that, otherwise things aren't going to work out. So my first coefficient is my x to the third, then my 7x squared. Maybe I should do this bigger. X squared, my 0x, and my minus 1, my x to the 0 power. Okay, and then I'm looking at this. When does that equal 0? Subtract 1, get 2x equals negative 1, which means x equals negative 1/2. So now this is what I'm going to write over here as my c, and let's find out if this is going to be a 0. Okay, bring down my first coefficient, so 6. And now let's multiply 6 by negative 1/2. It's going to give me negative 3. We're going to add those two. We'll get 4. Negative 1/2 times 4 is going to give me negative 2. 0 plus negative 2, so just bring down that negative 2 again. And then negative 1/2 times negative 2 is going to give me 1. And I got a factor. I have a remainder of 0. So this means a few things. If you remember from the warm-up, this means that x equals negative 1/2 is a 0. So it found one 0. All right, so now let's write our remaining polynomial plus 4x minus 2. Oops.
6x squared.
All right, so I said we're going to go all out because I looked at this and I said, hey, this can be factored.
Woo!
So let's use the AC method. So negative 2 times 6 is negative 12. Which of those factors are going to add up to 4? We got 6 and negative 2. Okay, so now I'll factor by grouping. First group has a GCF of 6x. What remains is x plus 1. My second group, I'm going to bring down my minus sign, which means I'm going to factor out a negative, and then the GCF is 2. And I'm left with an x now plus 1 because I factored out that negative sign. And then, now I just find the GCF of these two, which is the stuff I have in black. If my marker would cooperate. Okay. All right, and so now we're going to find all these zeros. We found 1, and we need to have 3. So it looks like we're going to get 2 more. This one, x plus 1 equals 0. That would be negative 1. And if I were to solve this one out, I would have 6x minus 2 equals 0. Add the 2, and then I'll divide by 6 and simplify to x equals 1/3. All right, and so here are my zeros. And remember, we started off by doing some synthetic division, saw that we had a remainder of 0, and then I decided to get crazy because this is probably what you're going to see in the future, and we continued factoring.
Woo!
Good job!
That is the video we have for you. What we expect you to do is do that paper that we both gave you for the next time we see you. And if you have questions, feel free to email us, send us messages on Remind, look other stuff up too. I know Josh is going to look on Khan Academy, so maybe find something there.
And talk to each other.
Talk to each other, yeah. Have a great day. Stay
Be
safe.
safe.